Hey class, I know we just started momentum, so I figured I would give us an example problem to get us going. We're going to do, this is a couple parts, we're going to do one part at a time. So what we have is we have a cannon shoots a grenade into the air. A grenade has a mass of 50 kilograms to begin with and travels to the right, which I will consider to the right a positive direction, with a speed of 100 meters per second. Our first part is just to find the initial momentum of the grenade once it's shot. So first thing we're going to do is we're going to draw a picture. Okay. So we have our little cannon. I'm not an artist. That will never change. We have our little cannon who's shooting a grenade off that way. It goes, we're going to say, perfectly horizontally. We're not going to worry about horizontal direction. And it has a mass of 50 kilograms and an initial velocity of 100 meters per second. Okay. So we got our little picture drawn. We're just trying to find momentum. Now, if you don't remember, momentum is just mass times velocity. So I take that, all we gotta do is plug in our numbers. First part's not too bad. We have a mass of 50 kilograms and a velocity, when it first takes off, of 100 meters per second. So if we do that, we plug that into our calculator, we get a momentum for the grenade of 5,000 kilograms meters over seconds. So that's our part one. So part one, not too bad to start out with, but we're going to bring it back and look at part two. Now we now have the grenade explodes in midair, breaks into 3 different pieces. I sort of have a picture there to give us the basic idea, shown on the figure. You managed to measure the mass of all fragments. I'm not sure how, but you did it, but only the velocity of 2 of them. So if you see the mass of this one is 20, moving with a velocity of 30 meters per second. You have a mass, second one's got a mass of 15 kilograms, moving to the right at 20 meters per second. And the third one has a mass of 15 kilograms, and I have it drawn to the right. We'll see if that's actually correct. So we want to find how fast that third one's going. So we're assuming they're all stuck together at once, and they explode into 3 different parts. So again, this is going to come down to conservation of momentum. So we know that initial momentum has to equal final momentum. So let's sort of break it out into its 3 parts. Our initial momentum is just the momentum of the whole thing, which is just your initial mass times your initial velocity, which is what we actually got before. We were actually given that initial mass and initial velocity. We actually solved for the momentum is 5,000 kilograms meters per second. But the final, you have to take all 3 pieces into account. So mass of the first piece times its velocity, plus mass of the second piece times its velocity, plus mass of the third piece times its velocity. Now we're going to do a little bit of algebra because we know everything except the velocity of the third piece. So we actually want to solve for that third velocity. So to do that, first thing we want to do is subtract both of these to the other side. So subtract that, we're going to get initial mass times velocity minus mass of the first one times its velocity minus mass of the second one times its velocity, and we're just left with third mass times its velocity by itself. But again, we still want to get the velocity by itself, so if we divide it by the mass of the third piece, or whatever you do one side, you do the other, it's going to give us an equation. And I'm just going to sort of flip it around here, where those are going to cancel out. We're going to get velocity of the third piece is just initial mass times velocity minus mass of the first, velocity of the first, minus mass of the second, velocity of the second, divided by the actual mass of the piece we're looking at. So looks like a lot, but it's not too bad. All we gotta do is plug in some numbers. So velocity of the third piece, well, we already know mass times velocity, we just said was 5,000 kilograms. So I'm going to just write that down. 5,000 kilogram meters per second minus mass of the first piece we were given was 20 kilograms. And it was going to the left, so I'm going to say left is negative with a velocity of negative 30 meters per second. And we're going to the mass of the second piece, which was 15 kilograms. And it was going to the right at 20 meters per second, so I'll just leave it positive, divided by my total mass of the third piece, which we said was 15 kilograms. Now, if we take all that, we can find the velocity of the third piece. We just plug in some numbers. It's 353 meters per second. Now, if you notice, that is a positive 353, which means it's going off to the right. And that is how we do it.